Is my screen visible?
Yes, Vivek. Yes.
Okay. So, good morning, everyone. Myself, Vivek Talwani. I'm working in ELK Stack and using it from last 5 years, from configuring to monitoring to troubleshooting to various other use cases for this. And I will be giving a demo session for in this big curriculum. And in the demo session, I will give you the overview of all ELK components and generalized view how it works. Okay, so I have set as a question section in the end of the session, end of this lecture. Please collect some questions and let me know where it goes. Okay, so uh, I'll start the session, and this is the introduction for the ELK stack. And what topics are we going to cover? Why big data tool is for use for log analysis? What is an ELK stack? Why we choose it? ELK stack introductions, ELK stack use case, and implementation of ELK stack and anomaly detection. These topics I'm going to cover in this lecture. Okay. So I have taken a small see why this tool has been so popular and why it's how it's being used. So there are various use cases. I have picked one use case in which I'll explain how it's deeply rooted to in each organization and how people are dependent on it. So I have taken a network operation and security management issues area. Consider yourself a network guy or security management guy. You will have to attend lot of users. It can be a faculty, staff members, students, or company members, or and etc. etc. And you have a lot of system which you need to monitor, which it includes router, firewalls, and servers. And since there are so many components, they should have so many logs, which comprises of net flow, syslog, access log, service logs, audit log, mail logs, and etc. etc. And the biggest problem of this profile or this job is like nobody will pinch out and nobody points and nobody asks for the update until something goes wrong. When something goes wrong, things becomes chaotic. So what for for this you will receiving lot of logs and event collections to make from multiple sources, and you have to collect those data in order to make your environment stable. And you have to accept those logs, parse those logs in a different log format. The log formats and log are in should be in a are will be in a large amount, because the every second router sends a packet and receives a packet, and you have to monitor it in order to troubleshoot when something goes on, something vulnerable has occurred in the system. And you should have a scalable architecture. Let's say if you have receive a high volume of traffic, it should support the existing requirements. And you should have an expert knowledge requirement of each and every component to in order to proceed that. If let's say if you don't have ELK stacks and you are using a traditional way, how will you treat this scenario? So you will set up multiple log servers to receive the logs from routers and firewalls and store them in areas, separate areas. Then you can use Unix command to grab whatever you need. Let's say if you want to if you want to search a vulnerability between 5 a.m. to 9 a.m., so you have to use these set of two Unix commands to search it. Either you can use AWK, you can use grab, or you can use sort the data, and or you can make a script also to do it regular basis. And if you want to do it on a regular basis and you want to send an email on your notification like this kind of vulnerability has been found between 5 a.m. to 9 a.m. on or other scenarios, you can use a cron job and add a script to that. So this is a traditional structure, and as you can see, it's very complicated. And if you still see that this is an easy one, just consider the facts. On an average, router and net flow logs are approximately 43 GBs of data. On a Wi-Fi one, it's almost 4.8 TB, and there would be additional firewall logs and server access logs. and the mail server logs will also be there for 18 GB, and uh, which comprises of POP3, SMTP, Exchange, OWA, and message tracking. And this is not an easy task. So that's the main reason ELK comes into the picture. And what is an ELK and why we choose it, I'll explain in the next slide. So I've explained it. So that's why these tools have been arises and people start using it and to make things easier. And why ELK only? Why not any other tool? See, Splunk is a market leader. It has various additional features. It comprises of ELK, but ELK is free tier has base defines some defined features which are usable, and it is a free tier. So that's why it's growing in a tremendous rate. That's why people are preferring ELK over Splunk, because has packages, or Splunk is a paid tool. It has features more than ELK, but it is not free. That's why ELK popularity is going day by day and day by day. You can see it from the graph. Okay, so why ELK? So it's a rapid premise on cloud installation, and it's easy to deploy, scale vertically and horizontally, ease and various API to use, ease in writing queries, a lot easier than writing map reduce jobs. Availability of libraries in most programming scripting language. Elastic offers a host of language clients for Elasticsearch, including Ruby, Python, PHP, Perl, .NET, Java, JavaScript, and more. There will be various tools available, and last but not the least, it's free and it's quick. Let's deep dive into the what are the components of ELK. Uh, so ELK, Elasticsearch, Logstash, and Kibana. These are the three major components to make it a compriser of ELK. And the Logstash is the base component. Logstash is a Logstash pipeline tool that extracts input from various sources of data, execute different transformations, and exports the data to the various target. In one liner, it just collects the logs and parse the logs and sends it to Elasticsearch. Then Elasticsearch is a NoSQL database that's based on a Lucene search engine. And if you ask me what is the one-liner on definition, it just indexes and stores the information. And Kibana is a visualization layer over the Elasticsearch, and it gives the visualization of the data which is being stored in Elasticsearch. So this is a basic architecture for ELK stack. So yeah, see if we talk from down top to bottom to top, so there will be a cloud in which has to be installed. There should be in a Logstash or Beats which ingests the data. Then after that, on the Elasticsearch, it just stores the data and create an index on it. And on the user interface, we use Kibanas to use it. And above top of that, we can use plugins to enhance the features like monitoring, security, and alerting. ELK modules, Elasticsearch, Logstash, Kibana, and Beats. And there would be additional plugins, alerting, monitoring, graph. Proactively monitoring, alerting based on Elasticsearch queries of condition, monitoring on the diagnose health and performance of lecture, and graph is exploration of see, ELK, as I told you before, it has three components. If it go deep down, it has more components, but the majority of the people ask for only three components. So this is a detailed structure of it. It has some extensive plugins also, which give more functionality and usability of this structure. Let's look into ELK stack. So how it works, as you can see from the simple structure picture, you have the data. It will be Logstash will process that data, and then it stores in the Elasticsearch. Elasticsearch creates the indexes, and it will in Kibana you will able to visualize it. Okay, let's start detailing of the small component. First component is Logstash. So what does Logstash do? It just manage events and logs. It just collects the data, parse the data, ingest the data, stores the data, and it's on Apache open source license. And it has how this architecture works. I'll explain. It has input. There are three components in this: input, filter, and output. Input means how your data is gonna be being processed. Filter means what kind of filters you want in a Logstash so that you don't receive unattended data or redundant data to make things easier. If you start storing all the data in the Elasticsearch, then what is in then this is not an optimized one. You will not able to search it properly, and you will consume a lot of space. So that's why filters comes into the picture. And output, in which output source you want to store the data in Elasticsearch. And and you can also, instead of storing an output Elasticsearch, you can output the data in various other formats also. Logstash is not only defined for Elasticsearch also only, it can be used in various other tools as structures as well. So how Logstash works, there would be input there. This is the you can say the basic three component file snippets. It would have an input, file, path, start position, in which input you will mention what is the log path you want to being analyzed, and from where it should be start from beginning, from end, or from the mid one. It has various options and various features. And after that, how you want to filter that? You want to send the whole data, just don't add any filter. Otherwise, filter, like if this is an access log you want to see in a defined format, you can mention like combine Apache log. This is a defined format, and your logs will only be saved in a defined format. Output. The output would be the Elasticsearch, as we are studying Elasticsearch only. Other than that, it can send emails, it can set to other components and uh, as well. So here in this slide, we have explained what are the input plugins available for Logstash. It can STD, and it can read events from standard input. It can file stream events from file like tail -f. Then it can read syslogs. Then it can message at events full of events for event IMAP. Read email for IMAP server, RSS output command line as an event, SM trap, which creates an event based on a SNMP trap messages, Twitter, which reads a Twitter from Twitter streaming API, IRC servers, then exec command, which captures an output or shell output in the event, Elasticsearch read query result from Elasticsearch. What are the filter plugins available? First is Xerox, pass unstructured event data into fields. Then is the one the other is Mutate, which perform mutation, which can remove mutations, or it can remove redundant data or add redundant data as according to your requirement. GeoIP will add geographical information about the IP address, and then which is a very important one. Date, which pass the data from field to use as a logstash timestamp for an event. Check IP address for the next one network blocks, CIDR, and drop all events, which just remove the data. And then next is standard output, which prints in standard CSV, then email, then Elasticsearch, then exec, then file, then MongoDB. These kind of output areas, it can send the data. It's not just like restricted to Elasticsearch only. Okay, so this is a basic example how a generalized Logstash file has been written. As you can see, there will be a filter one, input one, and output one has not been mentioned because we are just discussing only the filter part. If you can see the match, they have mentioned syslog timestamp. They are adding a syslog timestamp, syslog hostname, program, syslog PID, as well as syslog media. Why they have mentioned greedy data? Just to remove it. And yeah, and they have added date as well in this filter. So how this data is gonna be appeared? Like this: timestamp, diversion, type, host, syslog, program, PID, message. This is how your one-liner data will be some structured so that it can be stored properly in the Elasticsearch. This is a one more example. I'm skipping to this because this is both slides are explaining the same thing. And this is a GeoIP example in which they are adding country codes, country name, continent code, region. It can give so many things to your logs. Adding a GeoIP filter, and you can use a user agent as well. So yeah, There would be two types of structure installation available in Logstash. One is minimal and one is using filters. Minimal, in which you are not adding any filters, which I have explained you. You have a data source, you have input and output, you are sending all the data. And second one is using filter, in which you use filter plugins. There are also one more structure in which you can use FileBeat, which is an input plugin for Logstash only, which connects, which is attached to the FileBeat other in this structure, and you can send data to multiple Elasticsearch as well. This is one more structure available. And deploying and scaling, managing spikes through messages. So you can use Logstash. Okay, you can use a messaging queue between Elasticsearch and Logstash, and between Logstash and data source to make things easier. Multiple connections from Logstash is for high availability. You can use multiple Logstash also and send all those data to the messaging queue. Then after that, it will send one Logstash and then it will store it to Elasticsearch. That's how it's gonna be work. Okay, so next is Elasticsearch. Elasticsearch is I'm sorry, I'm wrapping it up early because I have list. Okay, okay. Then and multiple connection for Logstash for high availability, and then Elasticsearch. Okay, so based on the Apache Top Lucene engine, it's a search engine library, schema-free, REST-based distribution search engine and real-time analysis. It has a capable of handling scaling to hundred of servers, petabytes of structured and unstructured data. It's on Apache license 2.0. It's real scalable, comes from horizontal scale and schema flexible. These are the four big companies which are using Elasticsearch on a very large scale, like Wikipedia, which gives the full text speech highlighted to the search snippets. Add search as you want. Did you mean suggestions? Then Guardian used to combine visitor logs, social network data to provide real-time feedback to its editors in public response to the new articles. Other than that, Stack Overflow is also using it to use it a full text speech searcher and geolocation to make more correlation queries. And last, GitHub is using Elasticsearch to query 1.30 billions of data per day. So, what is the difference between Elasticsearch and relation? Why cannot we use relation database? So, and how Elasticsearch became so popular. So, Elasticsearch is nothing is just because database only, but works have differently. So in relation database, you have type, here it's table, here you have document, here you have row, and you have column, you have field, here you have partition, and here you have shards. Because of this sharding structure, this makes it so powerful and so flexible. And mapping, there is a schema, everything is indexed, and then you can use query domain specified language to query the data in Elasticsearch. So what is a shard? Uh, Shard is a single instance of Lucene. It's a complete search engine, and it has its own rights. Documents are stored in shard, and shard are allocated to the nodes to your cluster. As your cluster grows and shrinks, Elasticsearch will automatically migrate shards between nodes so that cluster remain balanced. So that's the main these are the main properties of shards, and which makes this so atomic to use. And shard can be used as a primary shard and replica shard. Each document or index belong to primary shard. A replica shard is just a copy of the primary shard. Elasticsearch clustering using single node. You can install Elasticsearch by using a single node, or you can use it as a multi-node structure only. And both have their advantages and disadvantages as well. And it depends on the use case how you want to use it. Uh, each cluster has one master node. One cluster has a number of indexes. Elasticsearch clustering second node. If let's say if you have added a one Elasticsearch and a one node only structure, three node structure, and you want to add one more node and adding six more uh, small structures. So a cluster can consist of one or one node or the same cluster name. All primary replica shards has been allocated. Each index has its own primary and replica shards. Clients can take to any other nodes to the cluster. See, the nodes one is a master node. It has the primary shards, and when you add one more node, it will have a replica shards. By default, replicas are being set to 0, which means one replica only available. To start adding more clusters, it will not have a replica. It will have some replica only, but replica is set to 0 and 1. Let's say if your both servers crash, it will create some problem in this structure. So the which I've explained in the next slide. So the more primary shards, the more cluster you have, the more primary shards. The more primary shards, faster will be indexing. Indexing will be faster and more scalable it will be. And if you opt for more replicas, then you have a faster searching, but and you are prone to failovers. You are safe from the failover. If something goes wrong, you will have another structure which will act as a primary, and you will be able to search data without any loss. Creating, indexing, deleting a document. So how these three queries gonna proceed in this in this three cluster architecture in which everyone has one primary and one replica. So client send a request to create an index or delete a request to the node one. The node in the document determined that nodes belongs to shard 0. It forwards the data to shard request number 3 where primary copy of shard is being allocated. Node 3 execute the rest of request on the primary shard. Once it's successful, it forwards the data in the parallel to the replica shards which is available on node 1. So it works on a step by step. It finds it in where the data has been located. It just created or deleted and just sends the signal to the other replicas. Then it will do it one by one. And once all the three has been synced, then it will report success to the client. That's just how it's gonna work. Retrieving a data for read request, coordinating nodes will choose different chart to copy each request because we are not editing anything. We are just reading. It can copy data from any master primary or replica shards. Client send the request on a node one. Node one use a document, and document belongs to shard. It's 0. Copy the shard 0 existing all three nodes. On occasion, it forwards the request to the node 2. Node 2 returns a document, which just returns a document to the client. Partial update to the document. When primary shard forwards to the replica shard, it doesn't forward the update. Instead, it forward to the new version of the full document. Why this feature has been there? Because to save data, save storage, you can use a partial update feature also. Multi-document patterns. This coordinate okay, so the coordinating node, which is shared to the each document list, it breaks up in the multi-document request and into multi-documents per shard and forwards in the parallel to the participating nodes. Once it's retrieved the answer for each node, it collects the response. So let's say if your index is very large and you still want to search it, then you can use a multiple part patterns also. It will divide your request in each parts and just search the data, retrieves the data, and collects the combined response and share it to you. Talking to the Elasticsearch, how you're gonna talk to an Elasticsearch DB? You can use RESTful APIs and with JSON over HTTP calls. The port is 920. Elasticsearch works on 9200 or 9300 in some cases, and you can access web line commands or using a curl command. So you can use curl. Let's see. We can see the example here. You can use a curl command to protocol to the host. What is the host for the Elasticsearch, the port and path, and the query string. Hi. So you can use JavaScript, JSON also. You can use, let's say, if you want to give for particular query or something else, you can use this following example. Use just like this following example. You can use curl get command, and you can use query to match all which consider the data. And there are other clients as well which is available to communicate like Java API, REST client, PHP API, Python API, and Perl API. Indexing a document. Although Logstash used to index the data in Elasticsearch, but you can also add data manually in Elasticsearch in using indexing feature. You can use curl commands, JSON one, in which you can use index, mention index, type, and ID, and you have to set the data in a document format, which is mentioned in this slide. And if you want to expost, you can put the data, you can post the data, and you can use whatever things required according to you. It just works same like insert, but you have to use curls and or APIs one. Retrieving a document, you can use once you have stored the data, you can retrieve the data, or you can retrieve whatever data you want using this JSON API only. These are the example. They can have other examples also, which is available on the relevant to the API basis. And using get command to retrieve the document, we can retrieve a specific document if it happens to know what ID it is. Performing queries. Using queries to perform the full text searching or parsing a query of a string value. See, these are the features available if you want to talk to the Elasticsearch manually, if you want to work manually. So this is a curl command in which you are searching a data according to the iPod and the format is YML. It will give the data in this structure, which I've explained in the Logstash also. Like it stores the data in this format, and it would take. And other than that, you can use query DSL also, which is a JSON request body. You can use get command to search the data according to the requirement. Last but not the least is Kibana. So Kibana is a search view interact which with data stores in Elasticsearch index. It just queries in execute queries on data, visualize results on chart, tables, and maps. It can have add and remove widgets features. It can share, save, and load dashboard as well. It's working on Apache license. So this is a very old snippet of La Kibana. Currently, we are in a very higher version. This is the first versions of it. Apologies for that. In which you have index part, you will have indexes, and these are being mentioned in the Elasticsearch only, in which how data is gonna search in an index, which we mentioned in first part Logstash only. The logs in Logstash we mention what index it has to be there for these logs. What index should be created? We can name any index we want, and Elasticsearch stores those index, and Kibana just visualize those in this. That's why if you're seeing this data snippet, you can see there are multiple names. These names are being mentioned by user only according to his requirement. So in this, there will be one visualization part also. This is a very interesting part in which you can visualize your data according to your requirement. You can create graphs, chart, line chart, markdown widget, metric, pie chart, and to visualize the data in more defined way or more clear way. Let's say if you want to search a GeoIP according to you can make markdown an area chart or what else and whatnot. So ELK use cases. So it has been used abundantly in many areas in social user location activities, user activities, machine log files, documents. If we talk about searching, it is being used by Wikipedia, Orange, and Oddies. And if you want to talk about logging tools and logging areas, it's being used by Netflix. Security analysis is being used by Cisco, and analytics is being used by Guardian. So this is a very old use cases and being shared by various teams in which they are praising ELK to how they are making their lives easier. And yeah, that's all for me. And questions.
Hi, I'm Saravanan here.
Hi.
Okay. Okay, Sharon, go ahead. I'll ask later. Okay, sorry. So Vivek, as part of our training, right, are we going to show this entire installation and configuration on the on-prem setup, or are we going to use any cloud instance for doing this?
See, what I have planned, I will create an VPS and whatever T2 Micro or whatever hosting platform, and install each component one by one, and there will be have a separate session for that, for separate labs for this. I will give theoretical session as well as I will give will show you how to install them one by one.
So you'll take even Docker also as a use case to show, right? How to monitor the Docker logs also.
I can use that. Currently, I am thinking of monitoring server access logs and server website logs and server logs to create in indexes and show you in the visualization part and as well as indexes part. If you want me to show you how it connects to the Docker, but for that I need to install it in a Docker environment. Then I have to show you then the use cases.
Uh, okay, I'm fine with that. So in addition to that logs, like, can you just show an example on the CSV file? Because in our company, we are using a software where it generates logs in the format of CSV file, comma separated values, right?
Not an issue.
So
I can
you can show
index
that.
those log according to the CSV as well. I need to
Okay,
replicate the
means
scenario.
CSV
Not
file
a,
is everything in the unstructured format, so that would be
that is not a problem. Logstash
log.
supports it, like Logstash supports, and you can use index it.
Even database logs also would be covered, right?
Right. Database log. See, Elastic, you can use Elasticsearch in each and every environment you want. If you want for a
Okay.
database, I need to replicate that in a one lab also. So these are the additions. See, I have left 2 or 3 labs according to the users, which is you only. So if whatever the majority one people will ask, I will give them with them will reserve those labs for those points only. If you ask me to how to connect to the Docker and want to analyze log, I will schedule the lab for that period. Or if you want database logs to be in search, I will schedule the lab according to that. So I have reserved 2 or 3 labs for this for these. Hap-
Sure. And that would be a single cluster, right? Meaning like the shards.
Yeah. Right now I'm using single cluster only. If they're required to explain in a multi-cluster, I will use Docker environment.
Yeah, meaning that how to keep the stars in different nodes. That will also be
If you want to understand one cluster is enough, then see, people do use one cluster structure where for the cost-effective solutions. In the big companies, I used to have I have seen nine nodes of cluster, 15 nodes of cluster. But that depends on the requirement because Elasticsearch, if you have to give separate nodes to the Elasticsearch to make it more usable.
got it. Thanks. Yeah, I'm done. Thank you.
You're welcome.
Hi Vivek, Rohit
Hi.
here. I just wanted to check with ELK, the data which is retained, say for example in the cloud, is there an option to have this, as per GDPR in some specific region, like if it's Germany, with the data will be in Germany, like nearest data center, that kind of. Uh,
See, for this, you can bifurcate or you can divide the data according to the GeoIP as well as network mask filter, which is available on Logstash part. So it will bifurcate the data. That is one part. It will store it. I need to check whether this feature is available or not. This is a very different use case, an interesting one. I have to check whether you are able to store data in a different zones for different areas.
like perhaps they have data centers in each region or something, like maybe in EU. I don't
I
know if
can
they have
collect the
templated.
data. See, I can add the filter and collect the data from where data is coming. And if I need to bifurcate that, I can make filters. I think I can make filters and send them to the different Elasticsearch according to the different areas. Yes, I think yes. But I need to replicate this scenario.
By default, where are the data centers located for this?
See, by default, it the way where you install. See, you have to install Logstash to each nodes where you want from where you want to receive the data. If it's on different zone, whatnot. And it you have to mention Elasticsearch cluster name in which you have to send the data. So if you want to in a same zone, you can mention the same node cluster. If you want to in a different zone, you can have to the different zone. But that will increase the latency. So in that case, you can use different Elasticsearch node on for the different zones and then combine them over the visualization. You can do that. So your data will be stored on Elasticsearch on different zones, and you can use a Kibana visualization on top of layer so that your data will be safe and in a different zones, and you can visualize it.
Okay, one last question from my side. Like for this training, what would be the lab topology? As in, like, say for example, can I replicate the same thing with say Visual? I mean, this Oracle, either Hyper-V or something, creating VMs for all this and have a home lab.
See, uh, for labs, what I have structured is like I will create a fresh VM in front of start with a fresh VM in front of you. Try to install each component which I've been explained and give you a small use case according to you. For your requirement, if you're saying like you want to you install something on a Hyper-V and replicate the environment for which you are looking for this sessions, I can
Either
help you with that.
VirtualBox, Hyper-V, yeah, any of those kind of things. Just because it's better to save costs than doing it.
Agree. I will see for yeah. That's why I'm working on a one cluster only. I will not. Yeah, I'll try to avoid three cluster or nine cluster structure to explain. And and yeah, I will start with from scratch. Like I will purchase a VM, a T2 micro or something else, and then we'll start so that you will have a clear picture. Like this is a fresh VM and you are starting from scratch so that you can replicate like if you create a VM hyper from a hypervisor or something else, you can easily replicate those scenarios.
Thanks, Vivek.
So I have a question. I'm trying to understand. Once you install Elasticsearch, how you gonna save all the logs? Because it need to be saved. You gonna save it in the same machine, or you gonna create a persistent volume and then
Mm.
save it outside of Elasticsearch? In
So
which
yeah,
one is going?
see, see right now in a cost-effective solution, I will install in a single node and try to analyze these logs from the same server only. And if you talk about your scenario, I'll explain. This is a production scenario in which
Yeah.
you want to install an Elasticsearch and you will receive abundant of data. For that, you need a persistence volume to
Okay.
save those data in that volume, uh, and that volume has to be attached to that server only. You don't if you start exploiting the data Elasticsearch, there is no use case because this will give an additional step and you will not have as efficiency as this thing. You can for this you need to attach a persistent volume on the same server only, which has a high read IOPS, and then you can use it.
Okay. Is any difference between ELK Engineer and ELK Developer?
Yeah, there's a difference. ELK Engineer used to install, configure, troubleshoot, optimizes. Developer will write query DSLs to use queries and to search indexes and to make. See, there is a special part available in the query DSL in which we use developer tools and different areas to make more features in Elasticsearch as well as to optimize and to use Elasticsearch according to your requirement. So these are two different scenarios. You want to understand how ELK works and you want to control it, that will become an ELK engineer. And you want to only develop, you don't want to install and don't want to understand how ELK works. You just only want to work on the data which is coming in a ELK and use it according to your need. Then you will query DSLs and you will become an ELK developer. These are two different
So,
things.
Okay, so which one we gonna be using, both or
This,
just
the
uh,
yeah, this is majorly working. This session, this classes will be majorly working on ELK Engineer. For developer, I will give it. There is one topic or two topics available, but this is not dedicated to the ELK developer.
okay.
Uh, are you going to deploy this onto AWS or Azure or any cloud, or like is it only on the?
See, I am thinking of public clouds. I'm buying a VM from there and then start from scratch. If there will be a requirement to install Azure and AWS, I will work on the majority. Whatever people will suggest, I will down create an account there and start from scratch. But that depends on the majority. If they are okay with the private cloud VPN, because that will include some cost of me. So it depends on the requirement of the all of the guys. If you all guys say nee, no, we want on Azure and we want on AWS only, well, I'll start on AWS. That's not a big problem.
So I just joined. I wanted to understand whether we are going to cover the ELK querying, how to use ELK installation, everything, right? Will be covered here in
Right,
this.
everything.
Especially the capping on the data based on filters would be prime, like especially for system logs and stuff.
See, capping is a
Syslog.
very important. Right, capping is a very important feature of it, because without that you will receive a lot of data and you will not able to optimize and use it according to your need. So yeah, filter part, grok part is an important part of this session.
Also, troubleshooting of indexes, right? Some indexes might not be useful, and we try to.
You can delete those indexes. I will show you how to delete and how to optimize this. You can use an additional filter also, which deletes the required indexes if they are not being used for 30 days, and this and according to the time frame also, because you have to delete your indexes regularly, or you have to set a bandwidth also. Otherwise, it will consume infinite storage.
Got it.
Also, like uh, s- if you want to install like on a virtual box, which flavor or distribution of Linux is suitable for this?
Uh, See, the from my experience, I was using CentOS from very last few years. But since it's giving some trouble, I am not confident I will show you on CentOS. Currently, I'm more prefer to Ubuntu boxes. If required, I can install on CentOS as well.
Yeah, I think CentOS is now not officially supported
Right,
also, no?
right,
Correct.
right. That's why I'm shifted to Ubuntu.
Ubuntu is
I
fine, I
started
guess.
my
Yeah.
right, I started my career in CentOS only. I have a majority of experience in CentOS, but since CentOS is not being supported, there are too many issues with repos, with and whatnot. So yeah, Ubuntu is just fine.
Thank you, Vivek, for today's session.
Okay. Any more questions, guys, before we wrap up? I accidentally make the pace fast. I wanted to wrap up at the right time, but apologies for that.
So, can we have an idea about when the course is gonna start? Because last time we took a demo and we never heard from you. So,
Right.
are we
See,
gonna
it's
expect you again? Mm-hmm.
see, that's the answer I cannot give. That's the visual part team will give the answer. How when we are going to start.
To start. Okay. Okay
Because
then.
from my side, I'm ready.
Okay. Okay then.
Anything else, guys?
Also in the syllable is talking about Elasticsearch REST API.
Mm-hmm.
Can I have an idea about it, like how does it work, or what is behind this Elastic REST API?
See, when the Elasticsearch has been designed, these query DSLs has been used to retrieve the data manually. If let's say if you don't want to use Kibana, you want to query the data and send the data to somewhere else in your own visualization tool. That's where query DSLs comes into the picture, and you can use developer tools in a UI as well, and you can use manually as well. From from that you can use it. Any more questions, guys, before we wrap up?
One more question, sir. Using FileBit, I know we used to ship logs, but for is that same with Logstash? Still, we use it for shipping logs also, or there's a difference between both?
Uh, Both works as the same, but if you have using it in a real world case use scenarios, and if you're using in a high volume areas, so what happens when you start using Logstash? See, there used to be you need to install one component in your server which will send the logs. Let's say if you have 1,000 servers and you have so 1,000 Logstash will be installed. So that's not a problem. The problem is, let's say you are having a high memory consumption, a high CPU consumption VMs, and you want to send those logs to the Elasticsearch. So if you install Logstash for these volume of data, Logstash will consume more high amount of memory because it was doing three tasks. It's taking input, it's applying filters, and it's shipping the data outwards. So what you can say, to improve this situation and to improvise these situations, beats started coming into the picture. So what happens, you just install beats because it's a very lightweight tool. It's just two things. It just is only one thing, not two. It just inputs the data from the server and just sends to the Logstash. Then Logstash do its job. I hope I will able to understand this point.
Yes. Yes, thank you.
So no more questions. Shall we disconnect, guys?
Yeah, sure, Vivek. From my side, it is.
Okay.
Thank you.
Thank you, everyone.
Bye. Have a nice week.
Okay. Thank you. Same to you. Bye.